All right, so for this final exam review, this is for the law of sines and cosines. We've already gone over a couple questions like this with the module 5 review, overall review, but we're going to do a couple more with this specific practice. You will be provided the formula for the law of sines and cosines. I'm not going to display it now. Some of us already have it memorized, but let's go ahead and just solve each triangle. For this, you should recognize for number 1 and 2 that these are right triangles. You could just do basic trig or Pythagorean theorem since they're right triangles. So I'm going to do 15 squared minus 7 squared, take the square root of that, and get my answer for this side length to be 13.27. 13.27. Just using Pythagorean theorem since it's a right triangle. Then to find one of the missing angles, I'm going to just work with my basic trig functions, SOHCAHTOA. So I'm actually going to work with A, so I could find A. I don't want to work with this 13.27. I want to work with what's given. I'm sure this is right. It's right. But what if I was wrong? So I'm thinking relative to this A, I know my adjacent and my hypotenuse. Cosine works with both of those. So cosine of A would give me 7 over 15. If I want to get A by itself, I'll do inverse cosine of 7 over 15, and that will tell me what A is. Make sure your calculator's in the right mode, degree mode. Inverse cosine of 7 over 15, we get 62.2 degrees. 62.2 degrees. Just do your 180 trick to figure out that this would be 27.8. 27.8 degrees. And that's number 2. We have all 3 angles and all 3 sides. Now we start getting into non-right triangles. This is the law of sines and cosines. All right, so this angle C, big C, is pretty easy because we'll just do the 180 trick. 180 minus 70 minus 52. We get that this angle C is 58 degrees. And I see, okay, I need to know little a, that's opposite big A. I need to know little b, but I do know what little c is. So since I know the entire C piece, I'm going to work with the law of sines. So it'll be little c over sine of big C, and let's just find A first. It doesn't matter if we did A or B first. Little a over sine of big A. All right, so we get 28 over sine of 58 equals little a, don't know, over sine of 70. Multiply both sides by sine of 70, we get 28 sine of 70 all over sine of 58 equals little a. All right, let's type this into our calculator. 28 sine of 70 divided by sine of 58, making sure we're typing it into our calculator appropriately, and we get 31.03. 31.03. We do the same thing, except we'll be working with the B section. So it'll be 28 little c over sine of 58, big C, equals little b over sine of big B, which is 52. So we end up solving it the same way. It'll be 28 sine of 52 divided by sine of 58. And we get little b is equal to 26.02. 26.02. We have everything. We have all 3 sides, all 3 angles. Cool. For number 4, can't do the 180 trick, but I know I have the entire little y section, big Y and little y. I need to figure out what big X is, because I have its side length, and I don't know anything about Z, little z or big Z. So little y, since I'm looking for the angle, let's just flip it so the angles are up top. So we'll do sine of big Y over little y equals sine of big X over little x. So that'll be sine of 71 over 31 equals sine of x over 24. Multiply both sides by 24, and then I get sine of x is equal to 24 sine of 71 divided by 31, 0.7564, 0.7564, dot, dot, dot. It keeps going on and on. To get x by itself, I do inverse sine of that. And I get big X is equal to 49.1. 49.1. 49.1. Now I could find big Z by doing my 180 trick. And I get 59.9 degrees. 59.9 degrees. So now I could use my law of sines again to find little z. So little z over sine of big Z, 59.9, equals, let's stick with y, 31 little y over sine of big Y. So then that would be little z is equal to 31 times sine of 59.9 divided by sine of 71. And we get 28.37. 28.37. 28.37. Boom. We have all three angles, all three sides. All right, 7 and 8. And I intentionally am not doing 9 and 10. I might end up just doing one of these. In fact, I'm just going to do number 8 just because I'm short on time. For this one, I don't know little t. I do know little s, but I don't know big S. I do know little r, but I don't know big R. I don't know an entire chunk, so I'm going to work with the law of cosines. So for this one, I'm not going to write it down, but we end up are going to get t squared equals s squared plus r squared minus 2 times s times r times cosine of big T. I guess that should be a capital T. The law of cosines uses A, B, and C, but you could replace them. So then we get t squared equals 25 squared plus 11 squared minus 2 times 25 times 11 times cosine of 119. Plug that all into your calculator at once. 25 squared plus 11 squared minus 2 times 25 times 11 times cosine of 119. And we get a really big number. T squared equals 101, 1012.64, blah, 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 blah. We square root everything, and we get T equals 31.82. So that is T. Now we just need to find our missing angles. So here we do the law of sines, since now we know the entire T chunk. So we'll do sine of T over little t equals, let's find S, sine of S over little s. So sine of 119 all over 31.82 equals sine of S all over little s, which is 25. Multiply both sides by 25, and we get sine of S equals 25 sine of 119 divided by 31.82. We get 0.687, and then we just do inverse sine of that, and we get S is equal to 43.4. 43.4 degrees. So now we just have r missing, so we'll just do r is equal to 180 minus 119 minus the s that we just found, 43.4, and we get r is equal to 17.6 degrees. 17.6 degrees. And now we have all three angles, 119, 17.6, 43.4, and all three sides, 25, 11, and 31.82. You would do the same thing for number 7, law of sines and cosines.